Awesome. Well, thanks so much. My name is Brennan O'Leary. I'm a developer evangelist with GitLab, and I'm here with Emily and Jessica, and we're going to be talking about Git. And Emily aptly named this conversation, Let's Get Started Together. And she knows very quickly the way to my heart, which is Git puns forever. So anyway, so I'm just going to talk a little bit about Git, and I'm going to try and go quickly and honestly, and it's a lot of information, but it's going to be way more valuable to use it in practice, and we're going to record ourselves kind of doing that. And I can show you some stuff, or we can switch and like have either Jessica or Emily, you can share your screen and we can play with different things. But because unfortunately, a lot of the easiest ways to learn Git is to make all the mistakes and use it like many applications in the world. But to just kind of give you some context first, I put together this. It's like 5 or 10 slides. So we'll talk about that. So first, like, what is Git? So Git is what's called a source code management tool, right? SCM, you might hear sometimes, short for source code management. And what is source code management? It's something you might need to answer before you know what Git is. So, source code for a website or an application, or even, for a publication, like documentation of some application. You can basically think of source code as a collection of a bunch of text files, right? For all intents and purposes. It can get a little more complicated than that, but just basically think of it as a pile of text files like we see here. So if the three of us are working on a project together and we're all contributing code to it, we're all going to make changes to different files at different times. Emily might be working on file A and B, and I'm working on file C and D, and then Jessica's also working on file A and D, right? And so combining all of those changes together is kind of can be a very complicated thing to do, and it's hard for a human to do it on their own, especially when, like I said, if Emily and I are both editing, or Jessica and I, sorry, are both editing file A, it's going to be complicated for us to figure out, wait, how do we merge these changes together, which is a term you'll hear a lot in Git. And so source control management tools do that kind of heavy lifting of bringing code together from different people, which again is just text files together from different people into one, final product, if you will. And traditionally, source code management tools were very like client server based. So that is, there'd be some server somewhere that was like the source of truth, and this is, where the repository is. And if you want to change something, you better be connected to that server so that your client knows what you're changing at all times. Git differs a little bit in the fact that it's what's called a distributed version control system. DVCS is another acronym you hear a lot. And what that means is, while there can be, and of course, since we all work at GitLab, we're very much a fan of centralized servers that help people collaborate, it doesn't necessarily need to be that way. And Git actually has a copy of everything on everyone's computer. So it distributes the ability to work on a given project, and that enables a lot of great things, and that's why Git's become very popular over the last 15 years. It enables developers to move a lot faster because they don't have to always be connected to a central server. They can make changes kind of on their own, kind of down their own path without a really heavyweight way to get back in to the main path. And so that's kind of what Git enables. And so digging a little, like a mile deeper into what Git is, the other thing is it's an open source tool. So Git, right, the Git in GitLab or GitHub, talks about the open source tool Git, which both of our companies were kind of based around. There's a couple other companies that have Git solutions as well. And so the fact that it's open source means all of those companies are contributing to Git and changes around it, and anybody that wants to use it can use it without going to a company to get Git. I'm going to try not to say Git again. Okay. The other thing is, okay, we talked about distributed versus centralized, right? It's a distributed system. It records every change and the whole history of every file that's ever changed. And it has a very simple and lightweight branching workflow. So when I say lightweight branching workflow, what I mean is it doesn't actually copy the whole repository every time I make a branch and want to propose a change. It only actually notates the changes I'm making, right? So that makes it super easy to have lots and lots of branches versus some older source control systems would say, oh, you want to make a change, Brendan? Okay, here's a whole copy of everything. And every time you make a change, we're going to make another copy of it. Git is very lightweight and a lot faster because it only is notating in the background the changes, and that's able to then compile into, okay, this is the current state of a given file. Then it's also can be used in the command line. We'll talk about that a little bit today. It also there's also a number of native applications, and when I say native application, I mean an application that's made to run on your computer to interact with Git. So there's a few of those out there. There's some that are associated with companies, like GitHub has one called GitHub Desktop, and there's some that are independent from any of the Git companies, like Tower for Git. And then there's also web-based apps, so GitHub, GitLab, those things that enable Git, but kind of have a web-based front end. All right, so let's talk about starting out. So I think I sent this all to you ahead of time, but if not, now's your time to go install Git. And for those of you that might be watching, I included this as well. So there's a different way to install it depending on which operating system you're running on your computer. Here at GitLab, we all run Mac. So you may have Git installed already. If not, it should magically prompt you to install it when you type Git and hit enter. In a terminal window. So if you don't know how to open a terminal, the quickest way I know to do it is to hit Command space, which brings up Spotlight search, and then I type terminal. That's how I still do it to today. There's probably some way to get to it through like the applications folder, but I'm lazy and just want to do that. And so then let's talk about some of the concepts around Git. So I made this very complicated, actually very simplified diagram, and then we're going to look at a more complex version of this. So again, the concept of Git is you just have a folder of files, right? So on the left-hand side, we've got our computer. On that computer, we have a folder full of text files, right? For lack of a better word, right? They might be HTML, they might be JavaScript, they might be some other programming language, but in the end, it's text for the most part. Maybe there's some images, but again, we'll ignore those for now. And that folder is where I'm going to be making my changes. And that folder then has within it what's called the local repository. So in a hidden folder inside that folder, it's keeping track of all of the changes I'm making automatically and comparing those to what's been added to the repository already. Like what's the latest state of the repository versus what's in my folder. And then my folder is called the workspace. And then my local repository is called the local repository. So when I make a change and I decide I want to move forward with it, I'm going to put it in my local repository. And then I'm probably going to do what's called pushing it. And again, we're going to go into more detail on another slide here to the remote repository. So when we say remote repository, again, that typically refers to a Git server like GitLab or GitHub. But it could be a native Git remote repository. So again, Git itself can host this. It's a little more command line driven, doesn't have as nice of a pretty interface as the other Git companies do. And then other folks are going to have their own entire copy of everything in the repository. So even if I've got something that's a work in progress that I'm pushing up to my remote repository, other people can look at it. So if Emily is working on something or stuck on something, she can push it up to GitLab, and I can actually pull it down and have everything that she's changed and committed up until that point on my computer and help out maybe. So to kind of go a mile deeper into that, let's talk about this. So here we have those kind of four areas I was talking about before. So, but there's actually a middle area here called staging area. So let's talk about that. So working directory, right? That on the left-hand side is just my local file system, right? My local set of files. And then let's skip staging for a second. Local repo is what I was just talking about. That's the local repository. And then remote repo there is, let's say, GitLab, for the sake of the fact that we work at GitLab. So here, if I want to get started with a new repository, let's say there's the website code that's on GitLab, and I want to download that and start making a suggested change to it. Well, I start by doing what's called a clone and a checkout. And so clone will bring the entire repository, again, all of the history of every change ever, down to my computer. And then checkout will check out a specific version of that. So typically there's a mainline kind of branch Traditionally, that's called the master branch in Git in general. And so that branch is kind of like, this is the production version of the website, for instance. So normally when I do a clone, it actually does the clone and checkout in one step, but it's good to kind of understand the difference. Clone is give me the whole repository. Checkout is bring me to a specific branch. Or let's say that I just have a new folder that I want to start source controlling with Git. So I've got a folder, I've got some files in it maybe, and I love Git so much that I want to add Git to it, or I want to collaborate with someone on it, so I want to add Git to it. If I say git init in a folder that hasn't had Git before, that's going to create a new empty local repository for me to use. So again, I could use that completely on my computer and do my own source control locally. But that's how you can kind of start from, okay, I've got something and I want to add it to Git. So from there, again, you're not doing anything that different than just changing what you want to change. So I'm changing things, and that's changing, of course, my working directory, right? So the working directory, again, just the directory on my computer, as I'm saving files to that, it's making changes. I can then say, and there's a missing command here, I can say git status, and when I run git status, it's going to compare the local repository, the most recent commit to the local repository, to what's in my working directory and show me what I've changed, what's different. Then there's this concept of a staging area when I'm ready to commit some or all of those changes. I say git add, and that adds them just to kind of a conceptual staging area before I've committed all of them. So I can decide to add some or all of those things I've changed. Maybe I'm done with 2 of the files, but I don't want to add the third. So I choose which ones I add, and then commit just basically takes a snapshot of the files as they exist at that time, right? So, and puts that in our local repository. So again, it doesn't have to necessarily be, and normally shouldn't be, a finished product at that point. It's just like, maybe I've kind of gotten to a certain point and I want to write down a message, because commits can have messages associated with them, and kind of take a snapshot. Like, here's where I am, and next I'm going to do this other thing that's going to change a bunch of stuff. So I want to take a snapshot now. And then I can send it to my remote repository with git push. So that's kind of that add, commit, push is a very common part of the workflow. That basically takes all the commits in my local repository that aren't in the remote repository and pushes them up there, so the remote repository has them. Then the kind of inverse of a git push would be a git fetch. So this would be, hey, give me all the commits that are in the remote repository that aren't in my local repository. And then again, I can check out, like, let's say I did git fetch and I got a new branch of Emily's that she was working on. I can then say git check out Emily's branch, and that would change my working directory to actually be her branch, not whatever I had been working on. And then at the very end, I can decide to merge 2 branches together. So you'll talk about merging a lot. GitLab calls it in the user interface a merge request. Before GitLab existed, GitHub existed, and they called it a pull request. But they're conceptually the same thing. They're both requesting a git merge, which is why I like our name better. But that's a different story. And when you do a git merge, it's taking 2 branches and bringing the changes from the one branch into the other branch. This is a great place for questions, because that was a lot. Does any of that make sense, first of all? I see nodding heads, which we won't see on the recording, but I will, for the record, say that there's nodding heads. Do you have any questions?
So far, so good.
Yeah. Okay. Great. So that's a lot. If you get this mastered, or you become an expert at this, rather, like, you're ahead of the curve for sure. But this is kind of a great overview of what the workflow is. So there's a couple other terms I wanted to talk about, and then I think we just dive right into actually touching files. So I've said branch a couple of times, like you would know what it is, but should probably define it. A branch is just an independent line of development. So again, there's typically kind of a mainline branch, like the production branch, again, traditionally in Git called the master branch. So that's where, like, we think of, this is the code that we're shipping out the door. Now, some folks have more complex workflows where there may be multiple of those kinds of branches. Maybe I have different branches for different releases. That can get really complicated. It's easier to think of it in kind of like a GitLab flow methodology, where there's one kind of main branch, and then when I want to make a change, I branch off of that branch, which basically just means, hey, I want to make a a copy called Brendan's change and make my changes on that branch. So I'm not making changes to the production system. And then I'm going to request to merge that branch, Brendan's branch, into the master branch. And then similar to that is what's called a tag. So a tag basically marks a specific point on time on a branch. So again, let's say I'm in that workflow where there's kind of one main branch, and we go and we release version 1.7. I might tag that point in time in that branch as 1.7. And now I know I can always go back to exactly what the code was like back then. Check out again, and we defined that a little bit earlier. That's, hey, I want to get a specific branch and make some changes to it. Commit takes your changes that you have made and staged and adds them to the repository. Push sends those changes to the remote repository. And then again, workspace we talked about, it's the directory on your computer where the repository is. And then there's a couple other things. We've talked about some of them. Untracked files. So there is a concept of like, I add a new file. Git doesn't know about it yet. That is called an untracked file. Sometimes that means, oh, hey, I want to add this new file to Git so I can track it. But there also are some files that you might not want to track. So like if I have a file that contains like secret keys that I'm using to connect to some server, I might not want to commit those. Or it's common in many programming languages to have what's called a package manager that brings in other open source packages. And then you only want to commit, hey, these are the packages I need, not here's all of the files from all the packages, because it could be hundreds of thousands of files. And so you might, those types of things, you use what's called git ignore to say, hey, yeah, this is in the folder, but don't think about it, Git, because I don't want you to commit it. The working area is any files that have been changed but not committed. So anytime I change something in my folder, it's a change in the working area. The staging area then are files that I've modified or added, and I've marked to, hey, next time I commit them, add these changes to the repository. Local repository, again, we'll say repo sometimes to be short, is the local copy of your entire upstream repository. So upstream is another term you might hear for remote repository. And that's a hosted repository, typically on a shared server like GitLab. And that's the same, oops, I'm going the wrong direction, which will do that every time. And that's it. Okay, so that's all I had slide-wise. I was hoping maybe that there were questions I could answer, or if you want, I can kind of do some stuff in Git. I don't know if you have some. The key, I think, when learning any program of any kind on the computer is you have to have something you want to do. If you don't have something you want to do, it's really hard. So if you two have anything that you're working on right now, we could look at that. Otherwise, I could just kind of make something up. I don't know which works for you.
I think the definitions are generally very helpful to have just a understanding of what we're trying to do when you work in Git, because understanding the language is key.
Yep. Yeah, so maybe, I mean, would it be helpful for me to kind of like go through, I had that diagram that's like all the steps. Maybe I could just go through that one by one, and that would maybe help us kind of like put that into practice. Awesome. Okay, cool. So I'm going to get a repository up, and I'm going to get that diagram up so that I don't lie and go a way that I haven't. And okay, so let me share my screen again real quick. Please stop me with questions though, because this is the unrehearsed, unplanned part of this. So this is the kind of thing that I'm going to do. So I'm going to clone an existing repository. So in our case, a repository that we use a lot at GitLab is this www.gitlab.com repository. So here I'm on GitLab. I'm in a group called GitLab-com. So we can see this up at my bar. You probably can't see it on the video at all, but I can zoom in here. So GitLab as a remote has the concept of groups. So I'm in a group called GitLab.com. That basically is GitLab commercial. There's also a GitLab org where we store our open source code, like for GitLab itself. And then www.gitlab.com is our way of saying this is our website, right? So if I'm not logged into GitLab and I go to gitlab.com, I get this, right? Our marketing website. So you can see when I log in, I'm actually a member of this repository. So I can clone it directly. If I wasn't, I could make what's called a fork of it. Forking is not a workflow that we talk about a lot at GitLab because we like the concept of everyone contributing on branches. But forking is a workflow you hear a lot about on GitHub because it's some open source tool, and we don't want a bunch of people that may not be in our organization committing all over the place. So we might say, okay, you fork it to your own. A fork is like an entire copy of the remote repository. So we talked about the local repository being an entire copy of the remote. Forking would be on the remote, make me a whole nother copy of this repository. That's just a quick thing on forking, sorry. But I'm just gonna clone. So here you can see I've got two options. I can clone with HTTPS or SSH. So those are just different ways of authenticating to GitLab or Git remote in general. This works for GitHub as well. So SSH, I've already got an SSH key that I've put into GitLab, into my GitLab profile. An SSH key is basically just a little key pair that gets saved on your computer. If we look here in my, well, it's not even spelled right. So I'm gonna have a bunch of things here. Oh, I didn't want to change directory. That's what, sorry. Live coding. If I list what's in my SSH folder, and there's a whole guide on how to do this. I'm not going to go through how to do this. There's this key pair called IDRSA and IDRSA pub. And so that uniquely identifies my computer. And then my ID_RSA is what's called a private key. So that's something I'll never share with anyone ever. But the public key I can share with everyone. And so this is the public key that's on my GitLab profile. And then when I do an SSH command to ask GitLab for something, it knows that I'm Brendan and lets me pull it down. So I actually already have a copy of this, but for the sake of the demo, I will make a copy. So I'm just in a directory here. I'm in my home directory, repos, demos. So again, this is just the directory that I want my repository to live in. So I'm going to say git clone, and then I'm just going to paste this button. I didn't explain. This button copied that URL to my clipboard. And I'm just going to hit Command V to paste it. So that's going to go out and get the whole repository. It's actually going to take a minute because there's a lot of images and all kinds of other fun marketing stuff. Didn't pick a great repository to start with because it's big. But you can see it's bringing down all of these objects. So it's doing a lot of work because I'm actually getting the entire history of the GitLab website ever, right? So every blog post, every image that's ever existed, all of that's coming out of my computer. So that seems like a crazy thing. Like, why would you want all that, Brendan? Well, again, it gives me the benefit of being able to look at it at any point in time on my local computer. And good news, the newest versions of Git support what's called a partial clone, where I don't have to clone the entire thing if I don't want to, which like for our website would make sense. I only need the most recent few changes. I don't need everything. And in true Julius Childs fashion, I'm just going to open the oven that already has the cooked turkey in it because I have a repository right here. So here I have my www.gitlab.com repository. So again, this is the whole copy of the repository. Now this one isn't updated, right? So here we'll look at something different. So the last time I updated this was, I'm not sure when, but I want to pull all of the changes from the last time I updated it to now. So I'm going to say git pull, and that's going to be a lot faster process, he said, hoping he was correct, because it's only pulling now the differences between where I was and what's changed since then, right? So it should be a lot less objects. We can see it's a lot fewer objects. It's only 1,500 versus to clone the entire thing was still working on the 780,000 objects in the entire repository. Now I'm doing both of them at the same time, which is probably making everybody sad, especially my home internet connection. But once that receives all of that, I'll have all of the changes that have been made, and I'll have the most recent version locally. And while that's churning, I'm going to open up what happens to be my favorite web IDE. So an IDE stands for an integrated development environment. It's just basically a place to edit code. And I'm going to open this folder there. So again, I'm just going to bring that over to the screen where you can see it. So this is called Visual Studio Code. It's just a little web IDE, or not web IDE, sorry. It's a little IDE. Again, I'm going to go to my repos folder, GitLab web, www.gitlab.com. That's where we were. I'm going to open that up. So again, that's going to show me all the files, every file that exists on the current master version of the GitLab web page. Once it's done, it is done. Great. And so I can go make a change. So for instance, maybe I want to change my bio, and I happen to know where that is. You know, it's a math, like I said, lots and lots of text files. So half the battle is knowing where something is that you want to change. But I know that Brendan's right here, and I might want to say, change my, I'm a merge request buddy. Yeah, I guess I'm still all those things. So maybe I want to say Brendan has a passion for software development and Git, or Git and iterating a process, right? So now I've just suggested this change where I'm going to add 3 things in a list, which is better than 2. And I'm going to click save. And so now, if I go, I'm going to show you 2 places. One, in the command line, if I say git status, we'll see, you've modified data team. And I can say git diff, which will show me the differences that I made. And so here you can see the change highlighted for me that I added git. But also in many web IDEs, I keep saying web IDEs. In many IDEs, we have a web IDE at GitLab, shameless plug. They also integrate with Git. So you can see here, this little guy lit up, this little friend lit up when I made a change. And if I click on that, I actually get a visual view of the difference. So many IDEs allow me to do that. And then I can commit from here. But on the command line, I would say git add, and I can say period to add every change that I've made, right? So this would be, if I made more than one change, I could add every change, or I can add a specific file that I changed by just typing that file's path. I'm actually not going to do that on master because I can't commit to master here. So first, I'm going to check out a new branch. So I don't have a branch that I've started yet. If I did, I could say Brendan's branch. But since I haven't started one yet, I'm going to say B, which will also branch at the same time that I'm checking out the branch. And now you can see that I'm on Brendan's branch. And I'm going to say git add everything. And then if I look at the status, now it won't be in red, it's in green because it's to be committed. So it's in our staging area. I say commit and M to add a message and say add git as a 3rd item. And so now that commit is in my local repository. You can see it gave me this crazy hash thing. That's the thing that uniquely identifies that commit. And I can say git push, and it's going to go up to the GitLab server and push this new branch to the GitLab server. And then many Git servers then will let you create the merge request or the pull request right from there, and GitLab's not alone in that. So then that merge request can go through the review process of getting merged by someone who has the right to merge code into the repository. And what did I miss from that slide? Anything? Let's see. Chrome. So we added, we committed, we pushed, we fetched. So I didn't show fetch, but I did do a pull, which does a fetch and a checkout at the same time. And the nice thing about that fetch is if I look at the branches, if I spell branch correctly, we can see all of the branches that I have here locally. So that's what the fetch did for me. Questions about any of that? I don't even know where we are on time either.
We're doing great on time. We still have, well, it's only 10:35.
Okay.
This is super helpful because I usually struggle through Web IDE because I'm afraid of this. Thank you, Brendan.
Yeah, no, it could be pretty intimidating at first, but it's, again, you have to have something you want to do. Step 1. Step 2 is just know that you can't break anything. The beauty of Git is you can't, like the way it's designed, even if you break everything, you can't break everything, right? Like The worst that you could possibly do is make a change to the website that breaks the entire website. A, we use GitLab CI, so that won't even get pushed live, right? It won't actually break. B, even if it did, you can always go back in time because Git is a magical time machine. And there's a great website I love for that. It's not exactly, there's a family-friendly version. Dang it, Git is the family-friendly version of it. There's a less family-friendly version that's easier to remember, but harder to put in a video when you're going to publish it. That shows you how you can, like, oh, if I committed something and realized I needed to make a small change, oh, guess what? You can amend a commit. You can make an amendment. Oh no, I made a commit, but I forgot to put a message in. Oh, again, you can amend it. Oh no, I committed something on master instead of my new branch. Good news, you can fix it. I committed to any of the wrong branches. Well, here's the commands to fix it. And what else? I need to undo a commit from 5 days ago. I need to undo changes I made to a specific file. And then the best is forget all this, I give up, which is just delete the file and folder and start again, which is not unheard of in Git. So yes, Git is a magical time machine. That's where I get that concept, which is at the top of this is, dang it, I did something terribly wrong. Please tell me Git has a magical time machine. It does. What else can I answer for you all?
I think that's
Anything
an
else?
excellent introduction. Thank you, Brendan.
Awesome. Awesome. Well, thanks. I'm going to stop recording now.